Hi Neet aspirants, welcome to Vari Medical Academy. Vari Medical Academy சார்பாக அனைத்து விதமான டாபிக் சார்ந்த ஒவ்வொரு வீடியோவும் இனி வரும் நாட்களில் உங்களுக்கு வரும். உங்களுக்கு இதை சார்ந்த சந்தேகங்கள், கேள்விகள் எதுவாக இருந்தாலும் கமெண்ட்ஸில் பாஸ் பண்ணுங்கள். எங்கள் எக்ஸ்பர்ட் ஃபேக்கல்ட்டி மெம்பர்ஸ் போடுற வீடியோஸ் பிடிச்சிருந்ததுன்னா ஷேர் பண்ணிக்கோங்க. அந்த வீடியோ ரெகுலராக உங்களுக்கு வரணும்னா சேனலை சப்ஸ்கிரைப் பண்ணிக்கோங்க. தேங்க்யூ. Wish you all the best.
Yeah, good morning students, and today we can explain work done by the gas in mechanical work by the gas. And in the previous classes we can explain a system, surrounding types of systems, and next to extensive intensive property. Next one is the heat capacity we can discuss. And now today heat energy and work energy. First one is I am writing work. What is work? Means mechanical way of transfer of energy. Work is mechanical way of transfer of energy. Transfer of energy. That is called work. What is work, students? Mechanical way of transfer of energy is work. Even heat is, these are the different energies, no? Work energy, heat energy. The mechanical way of transfer of energy is work, and non-mechanical way of transfer of energy, that is heat. Now what is the work? Different form of work. Work is equal to, what is the formula? Force into displacement. What is work formula, student? Force into displacement. That is called work. Different works are there. For example, electrical work. Is given. Electrical work means charge in the physics. Charge. Q is the charge into V. What is V? Potential difference. V is equal to potential difference. That is V. In physics type we are writing electrical work means Q into V, and Q means charge, V means potential difference. Next one also in physics, gravitational work. That is gravitational work means mgh. We can remember in gravitational work mgh. In up to, we have to remember in chemistry purpose, work is equal to force into displacement. This term we are using, but this terms electrical work and gravitational works used in physics. Now mechanical work done in mechanical, or mechanical work of gas system. What are the mechanical work of the gas system? Here is work done by gas means expansion. Expansion of gas at constant pressure. The formula is W is equal to minus P external delta V. This one please remember. Work done expansion, W is equal to minus P external delta V. Another formula also there, at pressure variable minus PdV. Here is V1 and V2. Here is pressure variable. Which formula we can use? Expansion. W is equal to work done of gas expansion. W is equal to minus P external at constant pressure, and W is equal to minus integration PdV V1 to V2. This is pressure variable. This one is the pressure variable formula, and constant pressure minus P external delta V. Next we have to write, remember what are the points? Work done expansion and work done of the gaseous system. W is equal to minus P external delta V. Work done on the system in chemistry, work done on the system is positive, work done by the system is negative. Please remember, physics and physics is somewhat principles are different, but in chemistry and delta V and volume is expansion. Delta V is positive, that is expansion. Expansion of gas, delta V is equal to positive. Now work done, W is equal to negative. Next, delta V is compression. If it is expansion, compression. Negative means delta V is negative, that is compression. Compression of gas. Compression of gas means volume is decreases. Volume decreases means W is positive. Please remember this one, very important. And in physics is it is given work done on the system is negative, work done by the system is positive. But in chemistry, work done on the system positive, work done by the system negative. Now here is volume, expansion of gas. Expansion of gas means positive. Expansion of gas is positive. And compression of the gas, volume is decreasing. Compressing means volume decreases. Decreases volume means compression. Now here is work is positive and here is work is negative. When work done by the gas, work done on the gas, work done on the gas, that is called positive. Next, we can take any one vessel. It is fitted with one piston. Here I fitted with piston, and here is a P gas, P internal gas. Here is applying P external gas. Okay, now P internal gas, outside is P external gas. Force is applying this. Okay, now what is the pressure formula, student? Pressure is equal to force in unit area. P is equal to F by A. What is the pressure formula, student? P is equal to force for unit area, that is called pressure. Here I am taking some small weights. After, if I remove these weights, what is happening? Here I remove the weight. These weights are I am removing. Initially I put. Now it is equilibrium. After I removing these weights means what is happening? From piston is displacement here to here. Now the position is changing of the piston from here. Actually here is there initially. After expansion of the gas, P gas means P internal gas and outside P external gas. P internal and P external gas. Now force or unit area. Now from here is there, I put the weight, I remove these weights. What is happening? The piston is displaced from here to here. The displacement is delta X. Delta X means large change because this position, so expanding. Expanding means this piston is from here to here displacement. Now work done of expansion of gas, work done by the gas, that is equal to, what is the formula? Minus F. Why I am writing minus? Work done by the gas, expansion. Expansion means negative F into displacement, right? Displacement. Okay. Now what is the force formula, student? Force is equal to pressure into area. Now write in the case of F is equal to, from this one I am writing F is equal to P into A. Pressure into area. Now F place minus P into A P into A. What is the displacement, students? What is the displacement from why it is piston is displaced? Because expansion of the gas. Expanding means gas is expanding means the piston is displaced from here to here, this position. Now into the displacement is delta x. Why I am writing displacement delta x? Where is the initial position is this? After I remove the weights means pressure. P internal gas is greater than P external. P internal gas. This gas is expanded from the piston position, also displaced from this point to this point. This displacement is called delta x. Now this portion I am taking volume of the cube. This area I am taking out, and volume of the cube. Now volume of the cube is equal to length into breadth into height. Okay na? Volume is equal to length into breadth into height. Now V is equal to length into breadth means area, height. What is the displacement height? That is h. That is equal to into h. This one in the place we can write it. W is equal to minus P external. Here is A delta x means height. This one is the here to here, height is displaced. Now height position we can write delta h means volume, write down. Here is delta V. Now W is equal to minus P external, delta V means V2 minus V1. This formula, expansion of the gas. Don't confuse students. First one I am taking expansion of gas. Expansion of gas is positive. Now work done by the system, negative. Next to compression. Compression means volume, actually more volume means increases means positive, decreases means negative, compression, and work is positive. Now I am taking one vessel and fitted with one piston. Here is P internal gas, P external gas. Initially I put some weights here, more weights I put. After I remove these weights, what is happening? P internal gas is greater than P external. What is happening here? The piston position is changing from from this position to this position, displacement. That displacement is delta x. What is the formula? Work done by the gas. Work done by the gas is negative. That's why I am writing work. Work means F into displacement, F minus F. Minus F is equal to P into A, because pressure is equal to force on unit area. Now F this side means P into A. Now F place you can substitute P into A. Yeah, P into A. What is displacement? Delta x. Delta x means this position to this position. Because of expansion of gas, displacement is delta x. Now delta x I am written. Now volume, this portion I am taking, this total I am taking outside. Volume of the cube, what is the volume? Here is volume is equal to, we can write L into B into H. Now length into breadth, area. What is the height? Height is displacement, this point to this point. Now H, in the position I am writing delta V, P external delta V minus P external, W is equal to minus P external V2 minus V1. This type of numericals are very, very, very important. And in this case, another equation also there. W is equal to minus P external dV V1 to V2. This one is a pressure variable. This formula is a pressure variable. Pressure here, yes, you are pressure variable changing. This equation we can use. And constant pressure, which formula we can use? Constant pressure, and use this formula. W is equal to minus P external V2 minus V1. Next, and different thermodynamic process also there, na? Different, what are the different thermodynamic process? Isothermal reversible expansion, isothermal adiabatic reversible expansion, different thermodynamic process. If already you know what are the formulas, W is equal to minus P external delta V. In the case of W is equal to minus P external and delta V means V2 minus V1. Use this formula. Next one is W is equal to minus integration P external dV V1 to V2. These two formulas are very important. Remember, these formulas are important. Numerical asking zone. In, for example, isochoric process. In isochoric process, what is the expansion? Work is equal to minus P external delta V. In this isochoric process, delta V is equal to 0. Now W is equal to 0 only. In this, W is equal to 0 in isochoric process. What is the isochoric process? Delta V is 0. This 0 means total 0. Work is 0. If you take isobaric process, in this isobaric process, in constant pressure means what is the formula? Minus P external delta V. This is the formula at constant pressure. And these two are important process. Isochoric process, I am taking delta V is 0, W is equal to 0, and isobaric process, constant pressure means what is the formula? W is equal to minus P external delta V. These are the formulas are using for numerical zone is very important. Next to isothermal reversible expansion of gas. Write down ma. Isothermal reversible expansion of gas. Expansion means W is equal to negative. Expansion of gas. What is the formula? We can write it. Isothermal reversible expansion of gas. Now I am taking vessel same. Now I fitted one piston I fitted. Here is P external pressure and P internal pressure internal. Now expansion of gas means initially I put the weights here, equilibrium is maintained. Initially equilibrium is maintained. If P internal is greater than P external, what is happening? It can be expansion of the gas. Expansion of the gas means, if we can write it like this also, P internal or pressure of gas, pressure of the system is equal to P external plus dP. P external plus dP. Here inside pressure is increases compared to P external. Expansion of the gas. Now when a gas is expanded means gas expand. If gas expand means temperature of the gas decreases. Yes or no? If gas is expanded means temperature of the gas is decreases. Now gas cooling. If gas is cooling. If how to again, the gas is this system, this is the diathermic boundary, this is absorbing heat from surrounding, absorb heat from surrounding, but remain temperature of the system is constant. Temperature means this gas is it is expanding. Gas is expanding means temperature of the gas is decreases, but if you gas is cooling, if it is this inside the cooling means it take heat from surroundings, that's why, but temperature of the system is constant only. Next, what is the formula? Pressure versus volume, pressure versus volume at constant temperature, Boyle's law. We can plot the graph like this, hyperbola. Now P external V is equal to PV equal to nRT. In the case P external is equal to nRT by V. From pressure volume rectangular hyperbola, pressure P external PV equal to nRT. Now we can use the formula, understand this concept. Initially equilibrium, after P internal gas is increases means it can be expanded, gas is expansion. The gas expanded means temperature of the system somewhat decreases, temperature of the gas is decreases means gas cooling. After heat, absorb heat from surrounding is there, na? This is system outside surrounding, it is absorbing it, but temperature of the system is constant. Temperature of the somewhat decreasing, gas is cooling, but temperature of the system is constant. But here is heat is decreases. Heat is, if temperature, you don't confuse temperature decreasing sir, temperature constant. No, heat is inside, the heat is decreases. Heat is decreases means it's slowly gas is cooling. Cooling means absorb heat from surrounding, but still temperature of the system is constant. Now use this one, the formula. What formula we have to write it? What is the formula, students? Expansion of the gas. Now write W is equal to minus P external dV, that is V1 to V2. We can in the book V initial, V final. V1 are lower limit, this is the upper limit. Now W is equal to minus integration V1 to V2. P external is equal to what I am given here? nRT by V. nRT by V dV. Okay na? Simple. Where is the P external? nRT by V. Simple, I am taking nRT. Now nRT take outside. W is equal to minus nRT. Outside I am taking integration V1 to V2. Next to dV by V. dV by V. Now W is equal to minus nRT. Integration dV by V means log base E V, V2 and V1. ln also we can write natural log. Natural log also we can write. Integration dV by V means log base E V. This is the natural log also. Sometimes are ln. ln also you can use, but I am writing log base E V. Now W is equal to minus nRT. Now log base E V2 minus log base E V1. Log A minus log B. Log A by B. Remember student, log A minus log B. Log A by B. Now write W is equal to, what is the formula? E minus nRT log base E V2 by V1. V2 by V1. Now log base E, ln converted to log base 10 means simple, minus 2.303 nRT log base 10 V2 by V1. V2 by V1. What is the formula? Isothermal expansion of gas. Isothermal reversible expansion of the gas. Use this formula. and W is equal to minus 2.303 nRT log base 10 P1 by P2. P1 by P2. This formula also you have to remember. Reversible, isothermal, isothermal, reversible expansion of the gas. Use this formula. In the vacuum and irreversible expansion of gas, irreversible free expansion of gas, free expansion of the gas. Now delta W is equal to 0. Now P external is 0 and delta U is 0, delta Q also 0. In this case, irreversible expansion of gas in vacuum pre-expansion, these all are 0. And intermediary expansion means P internal is greater than P external gas. In this condition, W is equal to minus P external delta V formula. This is intermediary expansion. What is the formula? Intermediary expansion of gas. Use this formula for intermediary expansion. And here these two formulas are. These formulas, W is equal to minus 2.303 nRT log base 10 V2 by V1, and this numericals asking zone is very important for chemistry. And